well. So what does the CEO of Netflix have to say? You know, think about it. When you watch a show from Netflix and you get addicted to it, you stay up late at night. We're competing with sleep on the margin. And so it's a very large pool of time replacing it. So let's have a look at this graph. So it shows when dopamine, the chemical responsible for pleasure in the brain, is released. And as you can see from the top line, social media, like, say, recreational drugs, deliver that same addictive high. So no wonder we're addicted to sleepless nights. So are we actually sleep deprived? Well, this study of almost 700,000 children, a literature review, showed that in the past 100 years, we've been on average sleeping 45 seconds less. And if that's the case, from the turn of the century, we've been sleeping 1 hour less. So to bring this closer to home, we conducted a small-scale study at our home institution, Imperial College London. And we surveyed them on lifestyle factors that they most wanted to improve. And from this, students actually said that they most desired to improve their sleep, and also that they needed improved time and energy management skills. And putting this in context collectively, the RAND Corporation, a leading non-profit think tank, says that developed nations, because of sleep deprivation, compromises on 2% of their GDP. And for the United Kingdom's economy, that would be £40 billion. Putting that in context, that is 1/3 of NHS England's annual budget.
Yeah, so Connor just told us about how sleep is important, and basically that we're not getting enough of it, but really, do we really know why we sleep? So let's try out this, as I would like to call it, a Socratic method. If you can all get your phones out and go to menti.com and enter 31, 73, and 21, we'll just have an interactive session, let's say, to basically ask the question, what is sleep, and basically why do we sleep?
Yeah.
What was the code again?
Yeah, it's 31, 73, 21. So we do see some response coming up. Yeah. So basically it has, well, didn't expect it to be that fast. But anyways, so basically we're talking about memory, we're talking about metabolism, we're talking about learning, we're talking about recovery. So basically all aspects of lifestyle medicine. Yeah. Cool. So let's get back to the presentation. How I would like to answer this question is through evolution. So as Dobzhansky famously stated, nothing really makes sense in biology except in the light of evolution. So what does this really mean? So we scientists tend to look across species. And what we found is that most animals do sleep. But sleep is really, if you think of it, we don't do much during sleep, right? We forego the opportunity to find mates. We don't really try to consume food. It's kind of competing with other aspects of lifestyle, as we say. So different animals sleep differently. And most animals, when we survey their sleep, when we deprive their sleep for a long and extended period of time, they tend to die, like cats and mice. During long-term sleep deprivation, they can die. So, for example, different animals sleep at different durations of time. Like elephants only sleep for 4 hours per day, while bats tend to sleep for 19 hours per day. That's just between cats and koalas. Yeah, they're all very cute. But what I I would like to bring your attention to is migratory birds as well as seals. So what do birds do when they migrate? Do they sleep? Well, the answer is they don't really sleep when they migrate, right? As what we understand of sleep. Actually, what they do is they perform something called the unihemispheric sleep. So they sleep with only half of their brain, just to keep being aware of threats and also being able to fly as well. This is also done in performed by dolphins, yeah, which performs unihemispheric sleep because they need to go back to the surface for air constantly. And there's another state besides sleep that we also often confuse as sleep in science, which is called torpor. Torpor is basically what happens when you don't have enough food or when the temperature goes really low. And torpor is found basically in hamsters and lab mice. So you can see that it's a bit of a problem when we're investigating sleep, because we might be seeing torpor instead. Yeah? And torpor, some people say that it's kind of short bouts of hibernation. Right. So we really looked at all those animals, and what did we see from surveying all those animals is basically we're very famously proposed model of sleep, the two process model of sleep theory. So first there's a homeostatic process, which is called process S. You can think of it as sleep drive, or as sleep depth, or as a homeostatic factor, a homeostat of your body. So basically, as you're not sleeping throughout the day, you accumulate this. This is what we call as sleep depth. So yeah, it accumulates through the day and drops down when you go to sleep. There's also the second process called the circadian process. Basically, this is the wake drive. If you think of it, it's entrained by light and darkness. So we wake up and it's to light, right? And we sleep when it's dark. Very simple. But what happens when we're sleep deprived? So as scientists, what we tend to do when we want to investigate the importance of something like sleep is basically we take it out of the equation. So what we do here is basically sleep deprivation, right? As we deprive a person of sleep, or an animal of sleep, the sleep drive gets increasingly high, right? So the process S, the homeostatic factor gets increasingly high. But then the circadian wake drive is still performing its what we call as sine curve. So here, for example, if there is an overpowering urge to sleep with a low wake drive, so in this part, we are really prone to sleep. But then, in turn, if there's a weak urge to sleep in terms of the circadian drive, so there's a high drive for wakefulness, yeah. But then we're still sleep deprived in this case, right? Well, studies have shown that actually we tend to stay awake. This will be shown in jet lag by my colleague later. Yeah, and this was shown also in animals, as I was saying. And for example, an animal or a model organism of choice is the fruit fly. So basically, what is sleep research in 2019? So let me talk to you about one of the major findings in 2019. So sleep, as we know it, is consolidated. So we sleep for one period of time. So we sleep, for example, at 12 o'clock, and then we wake up at 8, something like that. So one bout. But then other animals, like mice, they have several periods of sleep. So they sleep for as little as 5 minutes, and then as much as, for example, 3 hours. So they have different bouts, yeah, sequential, throughout the day. And one of the organisms that sleep similarly, so that also have consolidated sleep, are fruit flies. then make them sleep for only a minute or a minute and a half per bout. And how we did that is through a module that we invented called the ethoscopes. And what the ethoscope does is basically it has an HD camera that records sleep, and then we basically label the animal as sleep, and then we selectively deprive them of sleep by just rotating the tube. So let me just try to make this video work. You'll have a better understanding. Yeah, so this is the ethoscope. We're basically setting it up, the motors with tubes of containing flies. And then if you can just look at this one that's not moving and we think it's sleeping, basically it's gonna sleep right, just like that. So we try to do that throughout the day, which is quite funny in a sense. So what we did in this study is that we deprived flies of sleep throughout their lifetime. So an average fly lives for about 50 days, depending on whether it's a male or female and other stuff. But yeah, they basically live for 50 days. And what we found is that there's not a significant difference between the flies that were only able to sleep for a minute or or two per bout, per time, than normal flies. So, and from the machine learning algorithm that we try to label sleep, we saw that basically some flies don't tend to sleep really much. So as little as 15 minutes. So what do we know from this study? What we can infer from this? Well, what this study proposes is that there are basically a three-part component of sleep, which is, so there's obviously there's a vital part. Yeah, so we can't deprive an animal completely of sleep. Scientifically, that's quite hard as well. So we think that there's a vital part where if we deprive it completely of sleep, it's gonna have some deleterious consequence. Right, and then there's also this useful part of sleep, which is, so flies are quite different than humans, if you can say so. And we think that there's this useful part of sleep that's proper to each type of organisms. And finally, there's this accessory part of sleep, which is basically, it's sleep that we don't really need, for example. It's sleep on a Sunday morning. Right. So basically what I want to say is that sleep is not the absence of wakefulness. So when you sleep, your brain actually does something, right? So as the word cloud that we previously showed at the beginning, we know that sleep is to reconsolidate memories, that sleep is to recover, and those perspectives. So now I'm going to just elaborate on two basically perspectives of sleep really quickly. So first, EEGs. So something that we really know well, that we know really well about sleep are EEG correlates. So what are EEG correlates? Is basically, you can think of it as neurons in your brain talking to each other, right? So there are different types of EEG correlates. And we can separate sleep using those correlates into different stages. So so we can see that there's wake, REM, and non-REM, and deep sleep. Yeah. So during your REM sleep, your rapid eye movement sleep, that's basically when most of your dream occurs. And during deep sleep, that's basically when your brain recovers, or as I will show next, clears toxins. Yeah. So those are those EEG waves that I was talking about. So this is basically an EEG wave that's recorded when you're awake, and that's basically deep sleep. So with higher amplitude and lower frequencies. So what we know about clearing toxins, one of the most, let's say, convincing hypothesis is the glyphatic system. So the glyphatic system was proposed or refined by this nice lady here called Adebiyi. And basically what he proposes, so it's quite simple, this figure. There are basically three processes, right? Three basic components. So first, the cerebral spinal fluid flows into the brain through the periarterial space, and then it crosses here. So it crosses into the brain through what we call aquaporins. So those are just, as the name says, water pores, right? So the liquid component crosses the brain, and then there's this exchange between cerebrospinal fluid and interstitial fluid. So basically, fluid in your brain, which contains toxins. And then this basically washes off and gets reabsorbed in the perivenous space and gets cleared by the brain into the body, into the lymphatic system. However, I'd just like to point out that this model is not perfect. This is, something that's really important in the field of sleep, but it's not a perfect model. And the reason for that is basically Fick's law. What Fick's law is basically diffusion, and the problem with the lymphatic system is that basically the brain is packed with glia cells, with neurons, and all kinds of cells, so that it's not really possible for the for the toxins to be all cleared by this process. But we also know that neurons and glia cells do clear toxins as well. So basically what I want to say is that we don't have a complete picture. We have hypotheses that we're still constantly testing. And as you can see, this is quite recent. So it was pinned. So it was published in 2013. And Yizhou just recently did a talk on this system, and is still and she's still showing new hypotheses, new figures. So basically, what's important for students or medical students is basically sleep and learning, and that's a study that we showed. It's basically how all those research translate into for us taking a more clinical perspective. So as Connor mentioned, we surveyed university students about sleep, and in this figure, we show that most people reach a peak of sleep quality after 7.5 hours of sleep. Cool. However, we see that sleep quality does translates into less tiredness, but then this is quite linear. So what could we do to improve sleep quality? Well, what we propose with in line with previous studies is that we need to reduce sleep latency. So the quicker we go to sleep, the quicker we reach slow wave sleep, so deep sleep, the better our sleep quality is. So sleep quality is quite subjective, but it's basically how you feel after you sleep. So conversion with what Connor presented, one of the first picture that we showed of me sleeping in a sleep pod, well, we think that sleep pods are basically providing naps to students within campuses, and that could be one of the solutions to just increasing the mean sleep duration, which we show here that will increase sleep quality.
Can I ask a quick question?
Yeah, go ahead.
Is this continuous sleep, or does it not matter if it's continuous or in parts? Like, for example, a nap, can that contribute to that 8.5 hours?
Yeah. So basically, what other studies have previously showed is that when in absence of light cues and society, basically, humans have 2 sleep outs. So we don't really sleep consolidatedly, as we say. So right now, at this period, if there wasn't a talk or if there wasn't any light, basically we would all be asleep. So there will be one sleep session or sleep period at this time, around this time, and then their sleep at night.
Is this lunchtime?
Yeah. That's what happens. Yeah. And then you'll also see from Nick's talk. That's after, and he has other hypotheses about sleep as well. Yeah. So now my colleague is going to talk to you about what makes sleep go wrong.
Yeah, so, Yizhou's illustrated very well sort of why we need to sleep. And so, what makes sleep go wrong then? So let's take the example of obstructive sleep apnea. This affects 17% of the UK population in some way, and about 25% of males in the United States, putting it into context. So what is obstructive sleep apnea? Let's explain it word for word. So it's obstructive because when a person is asleep, the upper airways collapse, and that causes a apnea or cessation of breathing. This must last more than 10 seconds for it to be termed as an apnea, and the CO2 levels will rise. When the CO2 level rises, what happens? The neurophysiological arousal happens in order to try and open up the airways again. And that is successful, so the person doesn't wake up completely, but it reduces the amount of restorative sleep that is available, slow wave and also REM sleep. And so this leads to excessive daytime tiredness and also affects the quality of life that they have, of course. So if we look at this study, you can see the areas in purple. Those illustrate apneas. And then that is when airflow is reduced by more than 90%. The yellow sections represent hypopneas, when airflow is reduced more than 30%. And it can be quantified as such in the apnea-hypopnea index. 0 to 5 can be classified as normal, 5 to 15 is mild, 15 to 30 is moderate, and anything over 30 apnea-hypopneas in an hour is classified as severe. This is corresponded with, say, clinical history, and this is a simple questionnaire which is remarkably effective. So the Epworth Sleepiness Scale asks, for example, how tired you will be when talking to someone, how likely will you be to fall asleep out of a scale of 0 to 3. And when this figure reaches around 13, this is when we know to do further investigation, when it's above 13. Okay, so how do we treat obstructive sleep apnea? Well, lifestyle is a very good way, very good start. So lose weight, exercise, positional therapy, how you sleep, sleep hygiene. These are all helpful. In terms of medications, well, there isn't really any for obstructive sleep apnea. We have things such as splints, mandibular advancement devices, which we'll talk a bit about in a bit, and CPAP machines, which we'll also talk about. And there's, of course, surgical methods, which involve angioplatoplazy, which is essentially remodeling of the airway, and things such as, if you have deviated septum, straightening it, and also doing turbulence reduction so that there's better airflow. This can all help as well. So as you can see in this particular slide, on the left we have something, and on the right we have a Dyson vacuum cleaner. So what is that something? Well, that's a CPAP machine. And so what's the relationship between the two? Well, the CPAP machine is essentially a reverse vacuum cleaner. And it provides a continuous airflow so that's keeping the airways open for the user at night. So how does it work? So the person that suffers from obstructive sleep apnea, they put on this mask and switch on the machine. This provides a continuous positive airway pressure, CPAP, at a level pressure titrated towards their need. So for example, 11 centimeters of water. And things to be concerned about are whether or not the mask actually fits. You don't want to leak. You don't want the patient to be able to snore through the mask. And also the ramp time. So, some people just like the full effect of the CPAP machine blowing at them right at the start. But usually, people like a build-up from 0 to the therapeutic level so that they can actually fall asleep. And then that is usually how long it takes them to fall asleep, for example, 20 minutes. Compliance is very tricky with these machines. There's anything from 40 to 80%. And now with the new machines, we can do telemonitoring, so that in order therapeutic, it said that the patient needs to use it for around 4 hours at night. So this is something that we need to indeed look at when giving CPAP machines.
Hi. So I know this is probably one of the sleepier times of the afternoon. I remember this time in med school, you probably find it in the back of the lecture theatre passed out. So I'm going to get into how to sleep. So we're going to just try and give you some practical tips to help you on your way to making a habit out of getting a good night's rest. So we'll just start by asking what constitutes a good night's rest. By a show of hands, who's had over 7 hours of sleep today? Last night? Okay. You came prepared. Okay. Less than 7 hours? Oh, okay. That's fair. Sure. So let's jump in. So according to the American Academy of Sleep Medicine and Sleep Research Society, sleeping less than 7 hours. Sorry to ask you that question and give you these morbid. But it can do you some harm. So there's weight gain, there's diabetes, high blood pressure, stroke, depression, impaired immune function, and it can also impair performance. Let's not dwell too much on that. Let's just sleep a bit better tonight. On the other hand, sleeping more than 9 hours per night regularly can be appropriate in certain groups. So, for example, in young adults, those who've been undersleeping and who are recovering from sleep debt, and those with illness. 7 or more hours are recommended for optimal health, but you have to understand individuals are diverse, and the ideal duration of time for sleep is affected by factors such as genetics, environment, and behavior. So these numbers provide a rough guide, one that you can sort of trial yourselves for a week or two if you have time to sleep. But just getting an idea of how you feel after getting those extra hours in is important. You just have to listen to your body, and I think that's key. So beyond knowing how much time to allow yourself to sleep, you also have to consider where you're going to be sleeping. Okay, so sleep environment. Optimizing your sleep environment is essentially about optimizing comfort. So, for example, removing dust from your mattresses, making sure you're changing your sheets and ventilating the area where you're going to be sleeping regularly, getting a mattress that you find to be supportive enough, not one that leaves you with aches and pains at night. Ask yourself, is this mattress big enough for me? Are you the only person sleeping on the mattress, and are you getting enough space on the mattress at night? And is it firm enough for you? Is it soft enough for you? Is the temperature in the room right for you? So consider hospital environments. I think a lot of people here are medical students. Joy. Consider how notoriously difficult it is to get sleep in hospitals. Are you before clinical years? Mixed? Mixed, okay. So I'm sure that you've been to hospitals at some point. You will, as a doctor. Consider how notoriously difficult it is to get sleep in hospitals. Imagine that sleep environment. So you've got this barrage of bleeps of sensory stimulation. And I want you to now consider, is your room anything like that at night? Is your phone buzzing constantly, going off, it's lighting up and you're rolling over when you're groggy in bed to answer it or post something? Is your bed facing distractions? Are you dead, are you looking right at your work and your study materials every night when you go to sleep? Have you got lights on? Could you reposition your bed slightly to make it a bit easier to not be right in front of those distractions? Or could you even simply just lay with your bed at the opposite end of the head at the opposite end of the bed to try and solve that problem? Okay, so all in all, successful sleep takes some consideration, care, and also experimentation. So you have to be mindful of what works for you. Furthermore, you have to be mindful of what doesn't work for you and what could be having a negative impact on your sleep. So there are physical, mental, emotional factors. An example of a physical factor, just sleeping position alone. So in the context of, say, musculoskeletal pain, sleep position can make or break a night. People who have neck pain, for example, might find that sleeping on their backs makes the neck pain worse. and some people who have lower back pain might say that this makes it better. Hopefully you have neither, but even more important than that, one or the other, or having both could be problematic at night. In the context of heartburn and reflux disease, beyond seeing your GP to start medications, proton pump inhibitors, consider lifestyle factors that you can change. So for example, sleep position comes in here again. You could raise your head with relative to your bed, stop the acid shooting up at night. But then there are also other lifestyle changes, such as weight loss if you're overweight, stopping tobacco smoking, and if you're getting heartburn symptoms at night, avoiding late night eating, alcohol, and caffeine. So when trying to get to bed, there's a degree of emotional preparedness you need to that facilitates good sleep. You need winding down time. You should aim to find calm before bedtime. Best to get away from electronic devices and bright lights from screens. Or if you really do have to be near screens, you can get one of those apps that decreases the amount of light, certain spectrums of light that you're getting from your phone, so that it's not as disruptive to your sleep. So the next point links back to sleep environment. Bedroom is for sleeping. You need to build a mental link between your bed and sleeping. So if you find yourself unable to sleep, try and leave that sleeping area and do something relaxing elsewhere. So what you all hear quite a lot is that the bedroom is either for sleeping or for sex, if you're into that. Study materials away from your bed space. Try and clear your bed space, and so you can have a cleaner headspace as well. Relaxation can take the form of meditative practices. So there's moderate strength evidence that mindfulness meditation can significantly improve your sleep quality. So there are a number of apps actually at the moment. I think Headspace is a good one at the moment. It has there's these meditative before night Headspace apps. So you go on Headspace and it'll sort of guide you through what you want to do meditation-wise before sleep to try and get your night a bit more ship-shape. So finally, I just want to really urge you to be diligent and strict about sleep. So one way to really begin to value sleep is to treat it as a skill that you're trying to improve. So like any skill, you have to continue practicing, you have to put time in to reap the benefits. So we've already spoken about some of the outcomes of not sleeping well, but we're also thinking about the benefits of sleeping well, such as performance. I'm just going to close this section by going through jet lag a tiny bit, because it's a phenomenon that affects us as we, get on flights and cross time zones. Okay, so jet lag essentially happens when your endogenous body rhythms are out of sync with your environmental rhythms. And it's caused by rapid travel across time zones. So effects include difficulty getting to sleep, but also difficulty maintaining sleep, but also gastrointestinal upsets and muscle cramps, nausea and constipation. If you think about how long humans have been able to actually travel across time zones quickly, jet lag is a relatively young phenomenon, but whether you're taking flights for business, leisure, going on your electives, it can prove very disruptive to sleep and your health. So, practical methods for getting on top of it. Treating jet lag depends on two things. The duration of the stay in the new time zone, and also the direction that you're traveling when you get on the plane. So, if you're going to be staying for 3 days or less, then you don't want to mess with your sleep schedule, because you're going to get rebound symptoms when you dip back. But if you're staying for more than 3 days, then direction of travel comes into play. So for eastward travel, you want to do what's called phase advance. This means avoiding light exposure during the evening and getting early morning light exposure before traveling. So you can wear sunglasses during the evening. If you're traveling in westward, you phase delay, so light exposure during the evening and avoid early morning light exposure, and you can wear sunglasses during the morning hours. So we hope some of these practical tips help you to protect the good work that you're putting in improving your sleep practices. And I will just
Yeah, so you need to sleep to perform. Just a quick, short, just a few short slides to show you that sleep is really important for your performance. And I saw you guys yawning, which is really good because that's a sign that you're asleep, and that you're sleeping, and that you're not good for that you're not fit for driving. And basically, if you have less than 4 hours of sleep, there's a high chance of increasing of car crash. And also, I made this figure about sleep and learning. So basically, when you sleep, your memory consolidates, right? Depending on the duration of your sleep, you have different types of memory that's reconsolidated. For example, you have novel object recognition memory. So when you recognize a new object. And also, amongst other memories like object place memories. And when you sleep for an extended period of time, one type of memory is reconsolidated with respect to another.
Yes, and so what else is sleep important for? Or say, if you're a patient recovering from illness on the hospital wards, one of the most common complaints I get is, well, I'm sleeping not very well when you ask the patients how they are. It's not what they're actually sort of being brought into hospital for. And so we've done some preliminary studies so far with a noise meter, and as you can see, we've identified a range of frequencies which are there. There are some frequencies which are less present than others, and we're hoping to share our works with you in the future. So to finish on really, it's this framework that we've come up with called the Sleep Imperial Triad. And so we believe that emotional well-being and physical well-being is really tied up with your energy and time management, which leads to the quality and quantity of sleep which you can have, and we've termed it the wet square framework. So thank you all for listening. Absolutely delighted to have given you this talk. And I think we're out of time, so I'll be happy to take any questions if you come down and sort of speak to us. Thank you so much.
We're staying in here. We're staying here.
Yeah, what is this about?
Oh, I think I'm staying here. The plant, nature, nutrition convent. What did you vote? Oh, I've got that last.